Good afternoon, everybody. Welcome to NGC's first lecture for this year, and welcome to the University of Pretoria. I believe that you're going to enjoy your stay over here. I see the people are already quite busy on the chat box on the side of the screen. So I'm not sure what you can see from your side, but I can actually see everybody's names on what they're typing and everything from my side. Okay, I do see that the number of attendees is quickly approaching 250, so let me just quickly change the settings, which might mean that you guys can't post comments anymore if we exceed 250. Best professor so far, wow, in the 2 minutes that I spoke. Okay, so let us start. So before you guys overwhelm me with questions, let me quickly start the session, and then I will most likely answer most of your questions as I go along. So let's give that a shot. I'm quickly going to share my screen with you guys. Almost there. Is it just my screen that's flickering like crazy? Okay, just give me a minute. I'm just gonna unshare this thing. For some reason it was flickering like crazy there on my side, which will probably give you a nice headache in no time at all. Oh, that looks better. Okay, let's go back to that setting there. Okay, so I think the flickering is sorted out now. Okay, so as I said, please maybe just pause the questions for a moment. I will most likely answer most of your questions during this session. So firstly, as I said, welcome to NGC. I hope you're going to enjoy the module. I do enjoy presenting it, and I trust that that would overflow into you enjoying taking it. Just a couple of quick things. We've got something called the line alphabet, and we'll get more into detail of what is used for what later on. But basically for now, all you need to know is we have thin lines and thick lines. Usually thin lines can be used for construction lines initially, and later on you can use them for dimension lines, hatching, imaginary lines of intersection, and leader lines. Most of these probably stuff that you haven't heard of yet, so do not worry about that. And the two thicknesses for the lines are basically the reason why we said that you need to get two thickness or diameters of pencils. So I'm going to be making these drawings on the video with pen because I've noticed that pencil doesn't really show up clear enough on the camera. So I'm going to use pen. This is an erasable pen, so I can make my mistakes go away. First thing is, let's just quickly tune the focus. So for those worrying or wondering why I do a manual focus over there, sorry about that. The cameras continue to move the focus around, and then the text goes blurry every 2 seconds. So I usually lock my focus once I'm on a certain focal distance or size or whatever. So this is the UP title block. It's a paper with a little block at the bottom right hand side. So the title block is used to allow you to show your details, like your student number or your surname, in. Oh, sorry, I see someone says the session is full. Just give me a moment. I did change the settings. So for some reason we had a problem there. It seems like more people have just joined. So can you maybe on your, I'm assuming it's on a WhatsApp group or something, just ask the people to try again. I have now updated the session settings that you can join. And now the problem with this Blackboard thing is if I make the session open to more than 250 people, then you guys can't comment anymore. So I'm not sure how we're going to handle that. I must still find out from the ClickUp people about that stupid functionality of their system. Okay, so for now, I'm going to continue with my lecture. Bottom right of your paper, you have the title block. Now, in this title block, you have to fill in your surname and your student number, initials, and study discipline, title, drawing number, and all of that. But sorry, my brain just froze there on me. It does that sometimes. So this drawing paper, to answer the question about the people who asked about the drawing paper, I have posted a PDF of this paper on ClickUp for you guys already. So you can go and download this paper from there. And if you have access to a A3 printer, then you can print your drawings on A3 so that you can later just use your title block in later drawings. But you're also welcome to use A3 paper and just draw this in there by hand. So when you draw it by hand, you don't have to do the English and Afrikaans of each word. That will just waste time. So instead of van, you can just write surname. We're not going to be too fussy on the exact layout of this thing. It should just be more or less like the one on the screen. So in your van block, you can write your surname, initials, student number, okay, so I see someone just commented and said that some people still can't join. I say I do have 260 people on the session, so I think the 250 plus options should work. Please just ask them to retry to join the session. And thanks for the student who will convey the message to the other people who are trying to join in. They are joining the wrong session. That will probably be part of the problem. So this lecture is called G1L1 for, I don't have to say that to you guys. Yes, the session is being recorded. So under discipline, you don't write yes, I have discipline. This is your study discipline. For example, M for mechanical, B for industrial, and so on. This title is not your title, Mr. Miss or whatever you want to call yourself. This is the drawing title. So for today, the title is Isometric. Drawing number is not important for now. And the date, under date, please don't write yes, please. This is the calendar date, 15th of March 2021. I see some people have asked about the paper size. So please use A3 paper as far as possible, because you'll find later on when we draw some more complicated drawings that you would physically not fit it in on a A4 paper. So G1, L1, which students are included in here? This won't take long. Well, not from my side, my computer is very slow though. Okay, so this class is for industrial 4-year plan, mechanical 4-year plan, and N. I can never remember if it's metallurgical or mining. So all these 3 disciplines have this class at this time. Okay, good. Next question was, do you guys have to draw with me as I'm drawing now? The answer is no, not now, but later when I do the isometrics, it might help you. This title block we usually fill in using a pen, because if we're still drawing in paper on campus, then if it's in pen, it's not so easy for someone else to steal your drawing that looks better than theirs and change your name to theirs. So pen over here is a good idea. And next question is about EGD drawing boards. We will not use those drawing boards at all. All of the drawings in MGC will be by this equipment, your hand and your pencil. So all of them are freehand drawings. We don't really worry too much about straightness of lines. It's more about if the line is in the correct place. The CAD software, there is a link on ClickUp where you can go get that. Okay, so I'm going to go back to my lecture slides. Is a clutch pencil necessary? Well, I suppose it's a lot easier to use and more consistent than a normal pencil, so I would recommend it. Can you use your arm as a ruler? I think I can draw a straighter line with my hand than drawing it with my arm. So good luck with that if you really want to use your arm as a ruler. Okay. So I've quickly mentioned that we have the thick lines for the outsides of components. Thin lines are used later on and for construction as well. A dashed thin line is used to show hidden details. Again, we'll do that later on. Chain line is a long line and a short line, and a long one and a short one. We use this to show a center line of an object, a symmetry plane, or we can also use that to show section lines later on. Again, this is not too important for right now. So that's the long and the short of a chain line. Continuous thin freehand line is used for breaking of objects. Again, we'll do that later on when we do auxiliary views. All text is written using capital letters, the only exception being standard units like millimeters. So you write small m, not big M, big M. Text is typically 3 to 4 millimeters high, written left to right or bottom to top. Title block used you use a pen for your title block, and for the rest of the drawing later on, you'll still use pencil. I see someone is asking about the screen size that looks like a thumbnail on their computer. All you need to do is hover over it and or click on it, and then you'll see there's an option to pin that person, which is now me. So just pin my video, and then it should become big on your device as well. So, question about the slides on ClickUp. Yes, they are on ClickUp already. The CAD software we'll use later on in the semester. Then the question, why are the drawings freehand? Because it's cheaper. Because it's free. Now, basically, what we're trying to do is we're trying to teach you to draw correctly and not draw perfectly. So you can, for example, if you want to draw a certain isometric drawing, you can go and draw the whole thing with a ruler the whole time. But you'll find that it actually takes a lot more time to draw something with a ruler. And so drawing with a ruler for us doesn't teach you to understand what you're doing. It just teaches you to do what you're doing more neatly. So for us, there's no real benefit of drawing with a ruler except that it's neater, but your knowledge on what you're drawing is still the same. So that's why we draw freehand. Another question was, do you need a textbook or can you just use the slides? So the textbook is important because in your practical sessions, you are going to need the questions in the book to be able to do your cracks. So yes, the textbook is important. Another question is, if you have the graphical communication second edition, is that okay? Yes, it is perfect. The textbook that we are using has a couple of variations on it, but the variations are basically just some typos that were fixed. It's not really a massive difference in the books. Do you need the textbook this week? No, you don't. The practical classes start later in the month. They are actually shown on the daily timetable that I posted for you guys on ClickUp. Okay, hopefully it's opening soon. So on this daily timetable, it actually shows you exactly what is happening and when it is happening. So you guys are group 1, and here we are group 1L1. Then it says no practice this week. Well, this current week there's no prac either. Next week there's no practical. The week after that is your first practical on isometric. So this timetable is very important. It shows you exactly what is happening when. So please go have a look at this. Another question we also get quite often is, if you have your drawing utensils from school, can you still use them? Put it to you this way, I'm not going to stop you, but I can guarantee you that you're drawing slower than someone who does it freehand. Next question is, can you get the CAD software on a MacBook? Yes, you can get it on a MacBook if you install Windows on the machine. Okay, yes, so the next question was the 3-hour session that is on our timetable tomorrow is empty. Yes, so the first time that will happen is towards the end of the month. So for this week's practical, in the practical time, you can just simply relax. So no, it's not compulsory to draw freehand, but with the time available, you're probably going to be better off to draw it freehand. Okay, so AutoCAD apparently does work on Mac, but we are using SolidWorks. Okay, now I'm going to try to continue with my lesson. Next question is, will we not have your lectures until we have the practical? No, there are lectures and practicals. Is SolidWorks going to be free? It is free for you guys, the university paid for it. Okay, so an object can be represented on paper in two ways. The one is a 3D picture of something. There's my office artillery, just a 3D picture of that. Or the other way in which you can represent it would be multiple two-dimensional views of the component. Like here we have a front view, a right view, and a top view. For MGC, we're not going to make use of perspective viewing. Perspective is basically a 3D type of picture. I'm just mentioning this for the people who didn't have EGD at school. Perspective is a three-dimensional type of picture which looks a bit more realistic as compared to a normal isometric. Basically, with perspective, the size of an object is a function of the distance to that object. So the object becomes smaller and closer together as the distance from the viewer increases. A good example of that would just be your normal railway lines, which seem like they meet each other on the horizon, even though we know that they're supposed to be the same spacing apart all the way through. Otherwise, the train will have a bad day. So orthographic drawing is what we're going to do towards the end of the week. All orthographic drawings in MGC are drawn in third angle projection. So just for the EGD people, we use third angle. I know that you guys are used to first angle. For the people who don't know what these first and third angles mean and wonder where the second angle went, it is not really important. Basically, the difference is just, if you have a component and you want to draw a picture of what it looks like from the right-hand side, third angle projection says what you see from the right, you draw on the right. What you see from the top, you draw on the top. From the bottom, you draw on the bottom, from the left to the left, and then obviously a left view of the left view would just be a back view. That would be third angle projection. First angle projection is a little bit less intuitive, but it does the same thing in the end. So for first angle, your right-hand view is placed on the left-hand side, which is not very intuitive, but it's not wrong. For isometric views, we don't have a specific rule that says this view from this side has to always be the front. So that's why I have it highlighted in red. We don't have a set rule saying which view has to be the front view. You could also have this view here from the bottom right as your front view. I know for the EGD people that you did have a rule for that. We don't have a rule for that. Basically, all you need to do is make sure that what you draw in the 3D view corresponds to what we ask you in the question. Good. So an easy method for constructing an isometric view of an object would be to start by creating a block based on the overall dimensions. Draw the three-dimensional block and then add detail by cutting away the unused areas. Let me just zoom out a bit. And now I'm just going to freeze my focus. Okay, it seems like that is pretty good in focus. Okay, so we have this little friend of ours. We'll still see him a lot. So this is now a view of the object. If I want to draw what this thing will look like from the right hand side, I'll have to take it and turn it and draw what it looks like from the right hand side on the right hand side. So the question is, if you are drawing freehand, well, how will you get measurements? You will just estimate them like the next student has said. You can just use proportions and work from there. Remember, we do understand that you are drawing freehand, so we won't expect you to make a perfect drawing freehand. The idea of MGC is basically to train you to understand how to read a drawing, not specifically how to become a draftsman. So that's the important thing over here. Right, so I want to make a isometric view of this component. So I have a view over here. To the right of that, I've got a view, and above it, I've got a view. So this is kind of like the main one, seeing as that one and that one are projected from there. I see someone is asking about civil drawings. So for MGC, we don't really focus on civil drawings, more just mechanical drawings. Because the principles are pretty much the same, if you can understand a mechanical drawing, you'll understand a civil drawing as well. These dotted lines, I've just quickly closed the drawing views so that I can make them into little boxes and draw the boxes. So for an isometric, so this one I'm not going to bother about hidden details now. Isometric, I want a view at the bottom left, one from the right hand side and the top. So usually with isometrics, we make sure that you give me what I give you. I must be able to see that view, and that view in the 3D picture. Okay, so start with a line at 30 degrees. This one is about 1.5 times as long as it is high. Something like that. This one on this side should be more or less square. Right, so there we have the isometric box. Then I'm going to start to remove all the parts that shouldn't be there. So in this one's case, this top left-hand corner from the right-hand view. Something like that. Let's quickly just erase the lines that shouldn't be visible anymore. Okay, next thing we can do is remove this top corner in my main view. Sure, a bunch of people just left the session. I hope that's due to their own will and not due to some other ClickUp error again. Okay, so there we've removed this corner here. Next I can remove that little block from my top view. The key is that lines that are parallel over here should still be parallel in this view. So that one and that one are parallel, that one and that one are supposed to be parallel. Something like that. And then the circle. Drawing an isometric circle freehand is a bit tricky. So what we can rather do is, instead of drawing a circle, let's draw a square, because that's a lot easier to draw a square. Okay, so now that I have the square corresponding to that square, you'll notice where the circle touches the square should be exactly in the middle of each of these square sides. Exactly in the middle. Along with that, where it touches the line, it is also tangent to the line. So now I can draw it freehand, that it's tangent to the line and also touches the line. Okay, and that's basically how we would get to the isometric view of this little simple component. So just to recap, we start by putting a box around the object, then draw the box, then start to remove the material that you don't want. And there we go. We'll look at the center lines in the next example. Typically on isometric views, we do not show hidden detail. So the reason why we don't show hidden detail on isometric is it will become very, very complicated very quickly. This is still a reasonably simple example, but if you now think, if I go quickly add in all of the hidden details, we quite quickly get to a situation where this thing becomes excessively complicated to read. And this is still a very simple example. So yes, the next student said, is this not basically how you would cut it or machine it from a solid block of material. So yes, if you start with a solid piece of butter and you took a knife and you wanted to make this shape out of butter, then you would go and cut out this top corner, cut out that corner, cut out the block, make the hole. Good. So next question is, how will we grade this? So we would typically divide it into subsections. For example, skew plane might have a mark out of 4, like completely missing 0 out of 4, looks like mine 4 out of 4, and proportions in between as well. For the circle, you'll have a mark out of 4. This cutout over here would have a mark out of 4, and this big block cutout could have a mark out of 4, and overall out of 4 could make this drawing count out of 20, for example. So that's typically how we mark the isometrics. If it's a very basic one, we can even just do an impression mark, but generally this is how we break it down. You don't get a mark for neatness. That was my whole point earlier. You don't need to use a ruler or anything like that when drawing these things, because we don't give marks for neatness. If you want, you can use your drawing board if you have it, but you're probably just wasting your own time. Coolness. You can go and have a look on my ClickUp page. I made a lot of 3D PDFs. So on the ClickUp page, there's a tab called 3D Visualization Aid. So if you go click on that one, it has a number of PDF documents in it, which are 3D PDFs. So if you open it with a program like Adobe, you can't open it with Chrome, it just says it doesn't want to open the thing. So if you open it with Adobe PDF Viewer, then you can actually go and rotate the block the way you would want to see it. So it just makes it easier to get you to visualize what you should be doing. The title block that I showed earlier is available on ClickUp. The next question is, should EGD students get that model car? Now that depends on what you've been exposed to. So for the people who don't know what model car we're talking about, the model car is a small build-it-yourself car that you can buy from Wise Books. And I would really recommend buying that little car if you haven't had any mechanical experience before. For example, you haven't disassembled stuff like radio-controlled cars or worked on cars or anything like that. It has a lot of the features that we're going to look at in MGC. A lot of those are physically in that kit. So fasteners like bolts and nuts are there, shafts with special kinds of fit, like a press fit between the shaft and the wheel. All of those things are there as well, which will help you to get a practical feel for the theory that we do in class. Yes, so the other question was, is MGC more about understanding the diagram than being precise? It is exactly that. Okay, good. Here we have another isometric sketch example. So let's quickly do this one together. Yeah, so the app to open the 3D PDFs is Adobe Acrobat PDF Viewer. That's like the original PDF viewing application. And a list of all the pencils that you need, it's just 2 different thickness pencils. It's basically that. Okay, so this component looks something roughly like this. And now we want to make an isometric view of that. About the 30 degrees, yes, you just eyeball it. Okay, so this one is 6 blocks long and 4 blocks high. Right-hand view is 4 blocks wide, 4 blocks high. Not that it looks like it in my view, but I'll draw the isometric in correct proportion. Top view would be 6 long, 4 wide. So I'm going to do my isometric box. Something like that. Then the bottom left of this box needs to be cut out. So that's a 3 by 3 block. So I now basically just went and cut out this bottom left-hand block from my isometric view. Something like that. Yeah, I understand what you're saying about the lines that do look somewhat straight. Basically, my lines are quite straight because this is not the first time I'm drawing this exact example even. And also I've been drawing for a while. I had EGD at school as well. But school was a while ago. So the trick with drawing a line straight is to not go too slowly. So if you go very slowly, okay, I suppose I'm going to have to exaggerate this because my slow line will also be straight. So if you go too slow, it will look something like that. If you go faster, the frequency of movement just causes it to be more straight because you're not wobbling that much. Yes, it is basically a skill that you develop with time. If you can't draw a straight line from point 1 to point 2, you are allowed to do that. No problem. Next, I'm going to cut out this top right hand triangle over there. That line was not very straight. So there I've cut away this corner at the top right over there. Now we have an interesting thing. In the top view, we've got these two blocks, same in the right hand view, that block and that block. Now I have to figure out what is happening. Why is there a line over there? If I go to my main view, I see that I have a line going down and to the side. So I have a line there and a line there. Now with MGC, many times you'll have to think about ways in which it can look and then compare that to the picture itself and then see if it fits or doesn't fit the description. For example, if I quickly take this guy and I were to cut this right-hand triangle out, something like that. If I were to cut the right-hand side away, the left-hand side, well, from the top, I'll still see the rectangle and the other rectangle. From the right-hand side, I'll see the rectangle and the other rectangle. But from this side, I will not see these lines. The line going down and the line going to the side. Meaning that it is not possible for this object of mine to look like this. The other option would be if the left-hand side is cut away and the right-hand triangle is left in place. Something like that. And that's actually what it could look like. So you'll have to try to imagine different options for the view layout and then see which of those would actually work in your isometric. I would almost call it like a trial and error basis or method. Okay. Next one is the circle here at the top. So for that, I'm going to put a box around the circle. And draw this box in place. Something like that. In the center of each of the lines of the box, we'll have the circle touching. It is tangent at that point as well. And now I'm just going to erase the box. And then we're left with our isometric circle. Now, there's an interesting question. Would we see the arc in the bottom? So basically the other side of the hole. Now the rule is basically if the radius of the circle is bigger than the thickness or length of the cylinder, then you will see it. In this example's case, it is exactly one block and one block. So that means the bottom circle will actually just touch over there, so it won't be visible. In other examples, you might have a circle visible over there or not at all visible. Center line we show in the plane of the cylinder, something like that. This is basically just a symbol used to show the center of a circle. It's got a small cross in the middle of the circle. And long lines going out from there. So short lines and long lines. Okay, so I see there are people. Okay, so let me just quickly answer the question about the blocks. In this question, those were the blocks that I'm speaking about. So the isometrics will usually be given on a grid. So in this one's case, it was 4 blocks high and 6 blocks long. And that top is 1 block. So that was the blocks that I was referring to. The vertical center line we would typically not show in the isometric. It's not needed. And a question a couple of posts before was about where do you find the textbook? So if you go to one example where you can find it is Wise Books. Go to Wise Books and search for graphical communications. There you can find the book. They can deliver as well, so that does help a lot. So for today, there is not any homework. I would recommend though that you go through these things and make sure you understand what's going on. So no, you don't get marks for construction lines. The outside lines like the picture I sketched now, these lines are all done with the thicker of the two. There is not an ebook available, it's only the hard copy. I see we are over time already, so I think I'll call it time for today. Okay, and then in the next class we will continue with isometric drawing examples. The tolerance for drawing parallel lines is not too serious. They should just be more or less okay, not anything specific. Okie dokie, people, have a good evening.